let's look at an interesting probability problem. You have 3 boxes, each of which contains 2 marbles. In the first box, both marbles are silver. In the second box, there is 1 silver and 1 glass marble. And in the third box, there are 2 glass marbles. Suppose you select a box at random, then select a marble at random from the box. If you assume that marble is glass, what's the probability that there's another glass marble in that box? So here's the situation. We have our boxes, and we're going to put some marbles in the box. I just have stones, black and white stones, so that's what I'm going to use. You have 2 black stones in the first box, a black and a white stone in the second box, and 2 white stones in the third box. So if we pick one of the boxes at random, and then we pick one of the marbles out of the box we pick, so if I pick box 2, then I pick a marble at random out of there, I'm assuming that I pick a glass marble. What's the probability the second marble is also glass? In this case, it wouldn't be. But if we picked box 3, it would. This is a conditional probability. If you try to use intuition here, you might think that you're eliminating the first box because it can't happen, and so there's a 50% chance you pick the box that you want. It turns out that this isn't the answer. So let's take a look at how to find this mathematically. I'm trying to find the probability that the second stone that I could possibly draw is glass, given that the first stone is glass. This is a very standard conditional probability. So let me name my 2 events. I'm going to name the second event here F for first stone, and the first event here S for second stone. So I want the probability of S given F. Now we have a formula for this. It's the probability of S intersect F divided by the probability of F. All we have to do is compute these 2 probabilities, and then the fraction will become the probability we're looking for. Let's start with trying to find the probability of F. If I took a look at the whole situation, then I have 3 glass marbles and 3 steel or silver marbles. So 3 out of my 6 marbles are glass, which means there's a 3 in 6, or 1 in 2 chance that I pull a glass stone first. To find the probability of S intersect F, I'm looking for drawing the glass stone first and the glass stone second. So I can't be in box 2, I can't be in box 1, which means I had to be in box 3. It had to be these 2 stones. So there's a 1 in 3 chance that I picked the right box to start with. So my fraction becomes 1/3 over 1/2, which when you simplify, you have a probability of 2 out of 3, 2/3. So why isn't the probability 1/2? Well, the key is that every single one of my marbles is different. So I have 3 steel marbles, or black stones, and 3 white marbles, which I can label with the numbers 1, 2, and 3. My sample space then looks like this. I pick which box I'm going to take, box 1, box 2, or box 3, and then I pick which marble out of the box I'm taking, steel 1, steel 2, steel 3, glass 1, or glass 2, glass 3. This completely describes the full sample space because when I draw the one out of this particular box, I know what the other marble is that's left. If I draw steel 1, then the second marble in there is steel 2. If I draw steel 2, the second marble in there is steel 1, which is a different instance. It's not exactly the same case. So drawing glass 1 out of box 2 means I'm going to end up with steel 3. So when I look at it this way, then to figure out the conditional probability, all I have to do is restrict my sample space to the set that I'm interested in. This is the F that we had before. To compute the probability that I draw a glass stone second, given that I drew a glass stone first, I need to restrict my sample space so that I'm only looking at things where I draw the glass stone first. This is going to be crossing off half of my 6 things in my sample space. Drawing the steel 3 or steel 2 or steel 1 doesn't give me the condition that I want. So I really only have 3 things in my restricted sample space. So my fraction is going to be out of 3. Out of these 3 things, which are the ones that actually give me the event that I'm looking for, that I draw a glass stone second? Well, in the first case, I'm drawing a glass 1 and then steel 3. In the second case, I'm drawing glass 2, then glass 3. In the third case, I'm drawing glass 3, then glass 2. So out of these 3, the first one doesn't match, but the second one and the third one do. And so we get our probability of 2/3, just as we found when we did the mathematics. I hope that all makes sense, and let me know if you have any questions.